Good evening. Today I will be talking about clustering on NLTK. I will focus this presentation on k-means clustering because there are multiple ways of doing this, and this actually ended up being more complicated than I had anticipated, and therefore for this presentation I will focus mainly on the theory and on the idea behind this method of analyzing data, and I will provide a link for you at the end for examples. I think that will be the most beneficial and best use of this 15 minutes of time. First, let's talk about clustering itself. Clustering is basically the technique of grouping data into clusters or groups such that three conditions hold true. One is that there would be high intra-cluster similarity. In other words, between the data points within each cluster or each group, there should be a lot of similarity, and we will define it is on the person who analyzes the data to define what similarity means, and we will discuss that briefly in this presentation. The second point is there must be low inter-cluster similarity. In other words, between data points belonging to different groups, there must be very low level of similarity. That's kind of it makes sense. It's intuitive, but and I will show that with graphs later on. And for clustering, we do this informally. In other words, we find a natural grouping among objects. We don't do any controlled. We don't define anything for the machine. We let it naturally happen, and you'll see that. So this is a simple clustering graph. You can see that there are three clusters, there are three groups, and they have been clearly defined in this graph. And here it is important to point that we have two attributes or two columns if you had a table. One is debt and the other one is income. And for example, people or data points in this area suggest that there is high debt and low income, and here there is high income and low debt, and here we have low income and low debt. This is a slightly more complicated graph. It's the same idea. I use this graph just to show you that we can have multiple dimensions, and each dimension would represent an attribute or a column on a table. And in our case, it would be, for example, each word, each classifying word would have its own dimension, and we could have multiple dimensions, and we would use the same technique, the same measurement tools to define our data points into different categories or clusters. And here you can see a three-dimensional graph, or a data point divided based on three attributes. So why do we cluster? There can be many explanations for this, many reasons for this. One is we want to gain an understanding of the internal structure of the data. The other one is it's the partition itself. We want to partition the data. For example, if we want to segment the market, we would use clustering. We might use clustering in order to prepare for some AI technique that we might be using, or we might use clustering to discover a pattern, some internal rule in the data, and some structural pattern, some recurring pattern in the data. So you can classify clustering into different categories, and I will show you three of them. One is exclusive clustering, and in exclusive clustering you can see each group is clearly defined, so there is no overlap among the groups, and you can see that there is each data point belongs to one group only, one cluster only. And this is also referred to as hard clustering. And an example of hard clustering is k-means, which I will briefly emphasize on, and there is a package for it on NLTK. There is another type of clustering called overlapping clustering, and the name suggests the data points can overlap among different cluster groups. This is also called a soft clustering or fuzzy clustering, and an example of that would be the fuzzy c-means clustering, which we don't cover in this presentation. Another example of clustering is hierarchical clustering. One way you can think about this is this could, for example, be a tree representing the evolution of species over time. Now, a few points on this clustering technique or graph is that if you cut the graph from here, you will have two clusters, and if you were to cut the graph at this location, you will have you will have 4 clusters, and so on and so forth. And this is the hierarchical clustering. Now, one of the most important points in this type of analysis is the measurement for similarity or dissimilarity. Now, for us, we will focus on distance, and we can think of distance as similarity or dissimilarity, and we can have multiple we can have different measures of distance. Distance can have different measures, can be measured differently. One is the most popular, we've all learned that in high school or middle school, I assume, and that's the Euclidean distance measurement, and which is the most popular. There's also the Manhattan distance measure, which is quite similar to Euclidean distance. Instead of taking the squares, we only take the absolute values and we add the distances. Of course, I will show you a formula for the Euclidean distance to remind your memories. We might have a cosine distance measure. We could have a Tanimoto distance measure. We could also have a squared Euclidean distance measure, and so on and so forth. There could be many different measurement techniques. In the Euclidean distance measurement technique, which we have seen most certainly at some point in the past, turns the space, the Euclidean space, into a metric space, and we can measure the distance from point P to point Q or vice versa with the following formula. So this would be Q1 would be the first dimension of Q, point Q, for example, the x point of Q, and P1 would be the x point of point P. And this would be the second dimension of Q, second dimension of P, and so on and so forth. N would be the number of dimensions or attributes or columns in our table, or the number of classifiers that we might have, the number of words that are important to us in our specific examples. And this is how we would measure the Euclidean distance. Now, to k-means clustering. K-means clustering. This is the algorithm to compute the k-means clustering. This is not this is a brief description of the algorithm, and I will walk you through briefly on this. First, we have to define the number of clusters k, and then in the package itself, the NLTK package, we also have to do this. We have to define a k, and these would be the number of clusters, and basically we will choose that the machine will choose 2 random centroids, 2 points, or however many k is. So if k is 3, we will have 3 points, and then we will compute the distance from each data point, each data object, to these centroids, to the points that we draw. For example, we don't draw them, but just for you to visualize. And then we will group based on minimum distance. In other words, if there are 2 points, actually I will show you that on the next slide. And then we will repeat this until no object moves its group. And you will understand this with this very simple. Please forgive me for my bad skills in drawing. But suppose we have 4 data points here and then 6 data points here, and k is 2. So we draw two points, and these are our centroids, and then we measure the distance from this point to the red point, and this point to the second red point, and then we will group this data point based on its minimum distance. So this point would belong to this first centroid, and this point would belong to this centroid. And then we do this for all these data points, and we measure the mean of the distances for this group to its centroid, and for this group to its centroid. Forgive me if this is a little bit confusing. You can go and check these online, and then we will come up with a new set of centroids, and we repeat this until none of these points move group or switch group. Here we have a step-by-step of the k-means algorithm, and I hope this helps you at least a little bit. We measure first. We come up. This is random. These 2 points. So the first one becomes the blue point. The second point is the red point, and whichever data point that belongs to the blue centroid, we turned into blue, and vice versa. And then through the algorithm, we come up with 2 other centroids, and we repeat, and then we repeat again until none of these data points switch groups. So none of the blue go to red, or the red ones go to blue, and then the algorithm is complete. Here we can find an example of using NLTK and to do a k-means analysis. And on this page, you could also find an example of the other kinds of clustering that NLTK provides for us. Thank you for listening.